question says, let x be equal to t squared sine t. Prove that t squared is squared x all over the t squared minus 4t into dx dt plus t squared plus 6 all multiplying x is equal to 0. Right, so how do you start with this kind of question then? Your first start, of course, solution. Your first task is to write out given function that x is equal to t squared sine t. That's your first task. So what next? Next up, look out for the highest differential. This one here is first differential. That means I have to get dx dt. But in this equation here, my highest differential is the squared x all over what there? The t squared. That means for this one here, I will have to differentiate twice. So first things first, let's differentiate once first. And differentiating x with respect to t, I will have that the x all over the t. Question is this, for this question here, if I'm to differentiate this, which method do I use? Which method? Product rule. Why product rule? This is multiplying this. So this t and this are multiplying. Let me believe that by now you mastered product rule. So you know how it works. In this product rule, please, what's u here? T squared. What's v here? Sine t. What's, look up it, look up. What's product rule formula? V du dx plus u dv dx. So hold on now. What's your v? This one here, have it? Yeah. So product rule says v, which is this one here, sine t. So this is v. Next up, du dx. What is u? T squared. What du dx? 2t. V du dx plus, next up, u. What's u here? U is t squared into, this is v as sine t. So if v is sine t, what's the v dx? Or the v is t per se? I have cos t. This is product rule concept. This one here, differentiate this, I have 2t plus this one here, differentiate this, I have cos t. That means the dx dt is equal to 2t times sine t gives you 2t sine t. I'm done with this. Plus this and this gives you what there? 2t squared cos t. So this is the value for the x over the t. I have this. So this is now the x to t. We're not done yet. So that means we now have an expression for this. So the x to t, this one here is now this. But they said multiply the squared x over the t squared by this. So I still need to find the value of the squared x all over the t squared. That means I am differentiating again. So if this is the x to t, let's get the squared x all over the t squared equal to, if I'm given this question, which method would I differentiate this? This one here. Which method? Huh? This is the value of dx over the t. If I want to differentiate this, which method do I use here? It's not just a chain rule, but what there? Double chain rule. Use chain rule here, use chain rule here. That's how you work on it. So this one here is chain rule. This one here is also chain rule. Why? They are multiplying. Alright. So let's start with this one first. This is your u. This is your v. So chain rule says v sine t. Okay. Differentiate 2t. What do you get there? 2 plus u. That's 2t. Differentiate sine t. Get what there? Cos t. I'm done with this one. Plus, you now shift to this. This now becomes your new u. This one becomes your new v. So use product rule here, since they are multiplying. Becomes v, that's cos t, into differentiate t squared. Gives you what there? 2t plus u. That's t squared. Differentiate cos t. Gives you what there? Minus sine t. Next up, simplify this one as far as possible. So that's now equal to this and this. That gives you 2 sine t. 2 comes here. 2 sine t plus this and this. 2t cos t. So 2t cos t. Next up, this and this gives you plus this and this 2t, next up cos t, next up plus minus this and this t² sin t. Check out for like terms. Any like terms here? Any like terms? Right. Which of them there? 2t cos t, 2t cos t. If 2t cos t adds 2t cos t, what do you get? 4t cos t. Right. So it becomes 2 sin t. 2 plus 2 gives you 4t cos t. This man here minus t² sin t. With what we've done so far, we've gotten a value for the squared x over the t², which is this. We've also gotten a value for the x over the t, which is this. My next step will be plug in this value into this equation. If it gives me 0, I'm correct. If it doesn't give me 0 too, you're wrong. So the next step is now substituting. No, don't see what's this way. Record the function. What was that? We said x is equal to t² sin t. You have to prove what exactly? Prove that. Okay, don't worry. t² into the squared x all over what? The t² minus 4t into the x over the t. Next up, plus open bracket t² plus 6 into x. Alright, so let's prove this thing. So it's as easy as plugging in all our values inside here. It's that easy. Starting from here, so that will now be equal to the set t². So I'm having t². Next one says the squared x over the t². Please check, give me this value again. What was the value there? 2 sin t plus 4t cos t. Next up, minus t² sin t. So this one is now this. Next up, minus 4t into, please check again, give me the value of the x t there. 2t sin t plus t² cos t. So this is for this. Proceed plus, I'm having t², of course, t² plus 6 into x. What was x there? t² sin t. Alright. So my task is to expand it and see if it gives me 0. That's my task. Let's expand this. So this will now give you t² into this gives you 2 times t² times this. That gives you 2 into this, t² into this sin t. Right? 2 t² sin t. Of course, t² is multiplying everything here. Plus t² here gives you 4. t² times t, t cubed. Next up, cos t minus t² t to the power 4 sin t. I'm done with this. Expand this one. So minus 4 times 2 minus 8. T times t, t². Next up, sin t. Minus times plus, minus 4 here, 4. T times t², t cubed. Next up, cos t plus, of course, this one multiplies this one. So it becomes t² times t² sin t. Gives you what there? T to the power 4. t², t to the power 4. Next up, sin t plus finally 6 to this gives you what there? 6t² sin t. Right. So look at this. What do you have here? This will now give you, look at it. This will now give you, now, here's how to simplify this thing. Listen, my first considered variable here, listen, My first considered variable here is t² sint. Or perhaps you see from here, you say collect like terms. Collect like terms. My first collectible like term is t²sint. So run through this. Whenever I see t²sint, bring it to here. Starting with this, it becomes 2t² sint. No. This one here. So it gives you minus 8t² sint. Is that all? We start this one here. So it gives you plus 6t² sint. Is that all? Is that all? So I'm done with t² sint. Next up, t³ cos t. What do I have there? Plus 4t³ cos t. Please check. Any other t³ cos t? This one here. That becomes minus 4t³ cos t. Any other one again there? No. Next up, t⁴ sin t. Start with this one first. Minus t⁴ sin t. This one here. Plus t⁴ sin t. Is that all? Count them. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So it's correct. I always advise, after collecting like terms, make sure you count them. Alright, so that you don't mix any of them. Alright, let's stop this please. This is t² sin t, t² sin t, t² sin t. So let's work with the numbers. 2 minus 8 is what there? Minus 6 plus 6. So it gives you 0 into t² sin t. I'm done with this one here. Pick up the next variable. That's t³ cos t. I have plus 4 minus 4. That is what there? So you can see that plus or minus 0. So 0 into t³ cos t. Pick up the next variable. t⁴ sin t. Minus 1 plus 1. That is what there? So it becomes plus 0 into t⁴ sin t. Alright. So that now gives you 0 times this, 0 plus 0 times this, 0 plus 0 times this, 0 plus 0 plus 0 gives you what there? Proof. That's it.